Section 4.3, Dividing Fractions. In this video we will see the definition of reciprocal and the multiplicative identity property for fractions, the multiplicative inverse property for fractions, and the division definition for fractions. Suppose that you have 4 pizzas and each of the pizzas has been sliced into 8 equal slices. Therefore, each slice of pizza represents 1/8 of the whole pizza. Now for the question, how many 1/8 are there in 4? This is a division statement. To find how many 1/8 there are in 4, divide 4 by 1/8. That is, the number of 1/8 in 4 equals 4 divided by 1/8. On the other hand, to find the number of 1/8 in 4, figure 412 clearly demonstrates that this is equivalent to asking how many slices of pizza are there in 4 pizzas. Since there are 8 slices per pizza and 4 pizzas, the number of pizza slices equals 4 times 8. The conclusion is the fact that 4 divided by 1/8 is equivalent to 4 times 8. That is, 4 divided by 1/8 equals 4 times 8 equals 32. Therefore, we conclude that there are 32 1/8 in 4. Reciprocals. The number 1 is still the multiplicative identity for fractions. Multiplicative identity property. Let a over b be any fraction. Then a over b times 1 equals a over b, and 1 times a over b equals a over b. The number 1 is called the multiplicative identity because the identical number is returned when you multiply by 1. Next, if we invert 3 over 4, that is, if we turn 3 over 4 upside down, we get 4 over 3. Note what happens when you multiply 3 over 4 by 4 over 3. Multiplying the numerators, we have 3 times 4 equals 12 in the numerator, and multiplying the denominators, we have 4 times 3 equals 12 in the denominators, and 12 over 12 is just 1. The number 4 over 3 is called the multiplicative inverse or reciprocal of 3 over 4. The product of reciprocals is always 1. Multiplicative inverse property. Let a over b be any fraction. The number b over a is called the multiplicative inverse or reciprocal of a over b. The product of reciprocals is 1. A over b times b over a equals 1. Note, to find the multiplicative inverse reciprocal of a number, simply invert the number, turn it upside down. For example, the number 1 over 8 is the multiplicative inverse or reciprocal of 8 because 8 times 1 over 8 equals 1. Note that 8 can be thought of as 8 over 1. Invert this number, turn it upside down, to find its multiplicative inverse reciprocal is 1 over 8. Example 1. Find the multiplicative inverses or reciprocals of a, 2 over 3, b, negative 3 over 5, and c, negative 12. Solution. Because 2 over 3 times 3 over 2 equals 1, for a, the multiplicative inverse or reciprocal of 2 over 3 is 3 over 2. b, because negative 3 over 5 times negative 5 over 3 equals 1, the multiplicative inverse or reciprocal of negative 3 over 5 is negative 5 over 3. Again, note that we simply inverted the number negative 3 over 5 to get its reciprocal, negative 5 over 3. C, because negative 12 times negative 1 over 12 equals 1, the multiplicative inverse or reciprocal of negative 12 is negative 1 over 12. Again, note that we simply inverted the number negative 12, understood to equal negative 12 over 1, to get its reciprocal, negative 1 over 12. Division. Recall that we computed the number of 1/8 in 4 by doing this calculation. 4 divided by 1/8 equals 4 times 8 equals 32. Note how we inverted the divisor, second number, then changed the division to multiplication. This motivates the following definition of division. Division definition. If a over b equals c over d are any fractions, then a over b divided by c over d equals a over b times d over c. That is, we invert the divisor, the second number, and change the division to multiplication. Note, we like to use the phrase invert and multiply as a memory aid for this definition. Example 2. Divide 1/2 by 3 over 5. Solution. To divide 1/2 by 3 over 5, invert the divisor, then multiply. So, inverting 3 over 5, we get 5 over 3, and multiplying by 1/2, we multiply the numerators. 1 times 5 is 5, and the denominators 2 times 3 is 6. So the result is 5 over 6. Example 3. Simplify the following expressions. A, 3 divided by 2 over 3. Note that 3 is understood to be 3 over 1. So 3 divided by 2 over 3, if we invert the divisor and rewrite the first number, we get 3 over 1 times 3 over 2. Then, multiplying the numerators, 3 times 3 is 9, and multiplying the denominators, 1 times 2 is 2. So the result is 9 over 2. B, 4 over 5 divided by 5. Note that 5 is understood to be 5 over 1, so we can invert and rewrite the second fraction as 1 over 5. Then multiply the numerators. 4 times 1 is 4. Multiplying the denominators, 5 times 5 is 25. So the result is 4 over 25. After inverting, you may need to factor and cancel, as we learned to do in section 4.2. Example 4. Divide negative 6 over 35 by 33 over 55. Solution. Invert, multiply, factor, and cancel common factors. Negative 6 over 35 divided by 33 over 55 equals negative 6 over 35 times 55 over 33. Multiplying the numerators, we get the product of 6 and 55 in the numerator, and in the denominator, the product of 35 and 33. Now we'll factor each number in the numerator to get 2 times 3 as the factors of 6 and 5 times 11 as the factors of 55. And in the denominator, the factors of 35 are 5 and 7. The factors of 33 are 3 and 11. Now we'll cancel what's common. There's a 3 in common, 11 in common, and a 5 in common. So we're left with 2 in the numerator and 7 in the denominator. And the negative remains because we have unlike signs in our numbers, so the result is negative. So the final result is negative 2 over 7. Of course, you can also choose to factor numerators and denominators in place, then cancel common factors. Example 5. Divide negative 6 over x by negative 12 over x squared. Solution. Invert. Factor numerators and denominators, then cancel common factors. So inverting the second number, we get, and multiplying, we get negative 6 over x times negative x squared over 12. Factoring each numerator and denominator, 6 factors to 2 times 3, x squared factors to x times x, and in the denominator, we don't need to factor x. Factoring 12, we get 2 times 2 times 3. Canceling the common factors, a 2 cancels, a 3 cancels, and x cancels. We're left with negative 1 over 1 in the first fraction, which is just 1, and x over 2 in the second fraction. Negative 1 times a negative x over 2 is just a positive x over 2. Since they have like signs, the result is positive.